Good morning, friends. After the completion of discussion about the theory of waves, right? Now we are going to discuss about the illustration of this chapter. Now 15.1 is depends on the theory and also that is deleted from the board exam or the Gujarat board syllabus. Now 15.2 that is depends on the theory also. What are the quantities are used in wave equation, amplitude, wave vector, wavelength, time period, frequency. We have to calculate from the given equation of the wave, right? And also we have to find out the displacement of the particle at particular point. That means at a distance from the origin of a wave and at particular time. Now the illustration is given like this way, 15.2. A wave traveling along a string is represented by y is equal to 0.005 sine 80x minus 30. Numerical values are in SI unit. That means the amplitude is given in meter. A is equal to 0.005 meter. That is the wave vector is also given in SI unit, and here omega angular frequency 3 is also in SI unit. Okay. First we have to calculate the amplitude, then second wavelength of a wave, third C periodic time and frequency of the wave, and also calculate the displacement y of the wave at distance x is equal to 30 centimeter and at time t is equal to 20 seconds. So how we calculate it? We know the standard equation of the wave propagating in positive x direction. Y is equal to a sine kx minus omega t. As we compare the given wave with our standard equation of the wave, we can directly find out the some quantities. For that purpose, the given equation of the wave equation is given as y is equal to 0.005 sine 80x minus 3t. That is the equation 1. This equation compare with our standard equation of wave y is equal to a sine kx minus omega t. As we compare, so we obtain the first quantity, amplitude of a wave. Is this A represent this value. Therefore, A is equal to 0.005 meter. That is given in SI unit. Therefore, we consider directly its unit is meter. Now, 80 stand for the K. K is the wave vector. And K is equal to 80. Now K is given as the 2 pi upon lambda. We know that there is the 2 pi upon lambda. 2 pi upon lambda. Therefore, wavelength lambda is equal to 2 pi upon K is equal to 2 pi 3.14. K is 80. K is 80. It is simplified, we obtain that is the 0.785 meter. That is the 0.785 meter. That is the wavelength of a wave. Right? Now, third, there is a B portion. Now C. C is we have to find out the period and frequency. By comparing this, omega is equal to 3 radian per second. 3 radian per second we obtain omega, right? This omega is equal to 3. But we know that omega is equal to 2 pi upon t. 2 pi upon t. Therefore, periodic time t is equal to 2 pi upon omega, that means 3.14 upon omega 3. Therefore, 2.093 second is the value of periodic time. And frequency f is equal to 1 upon t. That means the 1 upon 2.093. So that gives the 0.778 second inverse of the hertz. 0.4778 hertz of the second inverse. That is the frequency of the wave. Now our aim is to find out the displacement of a wave at particular point x is equal to 30 centimeter and time t is equal to 20 centimeters. Now, displacement at x is equal to 30 centimeter and at t is equal to 20 second. Our equation is substitute the x and t in equation 1. Substitute in equation 1. Therefore, y is equal to 0.005 sin 80 into x, 80. X is given 30 centimeter, we convert into meter, therefore 0.3 minus 3 and time is given the 20. 3 into 20. Right? Therefore, the simplification of this is minus 30. So 0.005 sin minus 36. Sin minus 36. So sin minus theta is minus sin theta. Therefore, minus 0.05 0.005 sin 36. Now here the 36 in radian, we have to convert into degree. Therefore, 36 radian is equal to 36 into 180 upon pi. 180 upon pi. Therefore, we obtain 2064 degree. So directly, this degree we can't obtain its sine value. Therefore, we divide this 2064 into this part 1800 plus 264 plus 264. Taking the sign on both sides, then the equation number 2 just made. Therefore, sin 36 radian is equal to sin this 2064 degree is equal to sin 1800 plus 264 degree. 1800 is equal to 10 pi. Therefore, sin, there is the 10 pi. 10 plus 264. That is approximate. Okay. Therefore, we can directly add the sine 10 pi plus 260. That means the sine 264. So sine 36 radian is equal to this sine 264. We again divide into two parts sine 260. We directly not obtain 270 minus 6 degree. 270 minus 6 degree. Therefore, sin 36 radian is equal to minus cos 6 degree. Minus cos 6 degree. Substitute in equation 2. Substitute in equation 2. Therefore, y is equal to minus 0.005 into minus cos 6 degree. This minus plus 0.005 into cos 6 degree. Cos 6.9945. 0.005 here 0.9945. Right? Therefore, 0.00497 meter, that means 4.97 millimeter. That is the displacement of a particle at x is equal to 30 centimeter distance and time t is equal to 20 seconds. Actually, this calculation is very tough. But to clear a concept about how we can find out the displacement of a different particle, take the part for the propagation of the wave. For that purpose, this numerical we consider. Actually, this numerical is not asked. The first portion up to this, the wavelength, frequency and time period is asked to calculate for 3 marks. Right? This part is not asked. But to clear a concept, to find out the displacement of the particle at any time t, so we can calculate this method. Again, the equation of the wave traveling along a string is given y is equal to 0.005 sin 80x minus 30. All numerical values are given in SI unit. We have to calculate amplitude, wavelength, frequency and time period of a wave. Therefore, the given equation y is equal to 0.005 sin 80x minus 30, our given equation is 1. Compare this equation with standard equation of the wave y is equal to a sin kx minus omega. So directly we obtain the amplitude a is equal to 0.005. That is given in SI unit, therefore its unit is meter. So amplitude of the wave is 0.005 meter. Now, comparing the 80 with the k is the wave vector, so we obtain k is equal to 80 is equal to 2 pi upon lambda. Therefore, lambda is equal to 2 pi upon k. Substitute the value 2 pi, 3.14 k 80. So we obtain lambda is equal to 0.785 meter. 0.785 meter. Now, as we compare omega with 3, therefore the angular frequency omega is equal to 3 radian per second. But we know that omega is equal to 2 pi upon capital T, that means the periodic time. Therefore, omega is equal to 2 pi upon T is equal to 3. Therefore, T is equal to 2 pi upon omega. Value of omega is 3, 2 into pi, 3.14 divided by 3. Therefore, 6.28 divided by 3. Therefore, 2.093 seconds. And frequency of the wave f is equal to 1 upon t, capital T. Therefore, 1 upon this value of t. So we obtain 0.4778 hertz. That is the frequency of a wave. Up to this generally asked in exam. Now, how we find out the displacement of a wave at given position, given distance and given time? So equation 1 is y is equal to 0.05 sin 80x minus 3. Here we substitute the value of x and t, given value 30 centimeter and t is equal to 30 seconds. Centimeter converted to meter 0.3. Therefore, y is equal to sin 80 into 0.3 meter minus 3 into 20 seconds. Therefore, simplification of this is minus 36. We know that the sine minus 30 or the sine minus theta is equal to minus sine theta. Therefore, this value is negative sign here. Minus 0.005 sine 36. That is the equation 2. Now we have to simplify the value of sine 36. Here 36 is in radian. We have to convert into degree. For that purpose, 36 radian is equal to 36 into 180 upon pi. Therefore, we obtain 2064 degree. Now, 2064 degree, we divide in two parts, 1800 plus 264. Now, this 1800 we can take as a this way 10 pi plus 264. Here The 10 pi plus 264, therefore trigonometric function does not change sin 264. 264 directly, that is the degree, we not obtain the answer or the value. Therefore, we divide this way 270 minus 6. Therefore, sin 270 minus 6, we obtain the minus cos 6. So in short, sin 36 radian is equal to minus cos 6 degree. Substitute in this equation, therefore y is equal to minus 0.005 sin 36. Instead of the sin 36, we substitute the minus cos 6 degree. Minus minus plus, therefore 0.005 cos 6 degree. Now cos 6 is 0.9945, therefore 0.005 into 0.9945. We obtain 0.00497 meter, that means the 4.97 millimeter. That is the displacement of a particle. Now, next numerical 15.3, a steel wire 0.72 meter long has the mass of 5 into 10 is to minus 3 kg. Here the length is given 0.72 meter. Mass of the wire is given 5 into 10 is to minus 3 kg. If the wire is under the tension, T is given 60 Newton. So what is the speed of the transverse wave on this wire? So we know that the speed of a transverse wave, is V is equal to under root of P upon mu. Mu is the linear mass density, but we know that mu is equal to mass per unit length m upon l. Therefore, wave speed V is equal to under root of T upon m upon l. So this equation is like this way, under root of TL upon m. Substitute the value of T, L and m. T is equal to 60 Newton, L is given 0.72 divided by the mass 5 into 10 is to minus 3. We obtain the speed is 92.95 meter per second is the speed of a transverse wave in a metallic wire kept under the tension of the 60 Newton. Again, the length of a wire is given 0.72 meter. Mass of a wire is given 5 into 10 is to minus 3 kg. Kept under the tension of the 60 Newton. What is the speed of transverse wave in this wire? Now the speed of the transverse wave is given by the equation. Already we derived this equation. V is equal to under root of T upon mu. T is the tension and mu is the linear mass density of a wire. Linear mass density of a wire is equal to mass per unit length of a wire, m upon l. Substitute the value of mu as m upon l. Therefore, V is equal to under root of T upon m upon l. L is in denominator of denominator, comes into the numerator. Therefore, under root of TL upon m. Substitute the value of T, L and m. Therefore, under root of T, 60, L, 0.72 m, 5 into 10 is to minus 3. As we simplify and take the square root, we obtain 92.95 meter per second. Clear this? Okay. So next numerical we discuss in next thing. So that is the most important numerical. Keep in mind that there is also asked in objective type question and also in numerical.